Hi my viewers, welcome once again to my channel. Thank you so much for your continued support. Thank you for subscribing to my channel. Thank you for liking my videos, and please, if you are new in my channel, subscribe for me, like my videos. I really appreciate. So today I want us to look at some initial equations, and as you know, these are some of the equations that involve powers. And for us to solve this kind of equations, we use the laws of logarithms to solve them. The term initial is coming from the power. Index means power. So when you have an equation that has an index or a power, then for you to solve them, you use the laws of logarithms. We apply the laws of logarithms. So let us look at how you solve this. So let us look at the solution. If you are given, like our example 1 is 3 raised to a power of x is equals to 27. You can see I have 3 raised to a power of x, and x in this case is my index or the power. And I have 27, and of course 27 is the same as 27 raised to a power of 1. So for me to obtain the value of x in this case, I'm going to apply the laws of logarithms, and I'll now introduce logarithm. A logarithm to base 10 both sides. So if I introduce natural logarithm both sides, I will have a logarithm of 3 raised power x to base 10 is equals to logarithm of 27 to base 10. So you can see I have introduced logarithm to base 10 both sides. And then from there, we have the law of powers, which says that if I'm given logarithm of a raised to n, it's the same as having, I take this n to this side so that I have n logarithm of a, like that. So in this case, I have a logarithm to base 10 of 3 raised power x. So I'm going to take this x to this side. So I will have x logarithm of 3 to base 10 is equals to logarithm of 27 to base 10. And then from there, for me to obtain the value of x here, I will divide both sides by logarithm of 3 to base 10 divided by logarithm of 3 to base 10, so that the whole of this one will cancel out. And then my x is equals to, if you take from your calculator logarithm of 27 divided by logarithm of 3, you will have 3. And then our value of x becomes 3. You can confirm this. If you have 3 raised power x here and x is 3, you will have 3 raised power 3, which is what? Which is 27. So that's how we solve some of these initial equations that involve powers. Let us look at example 2. So our example 2, we are told to solve the equation 2 raised to power x is equals to 3 raised to power 1 to 4 significant figures. So let us look at the solution. So the same way, if I have an equation like 2 raised power x is equals to 3, you can see that this equation is involving powers because I have 2 raised power x and 3 raised power 1, the same as 3 raised power 1 here. So for me to obtain the value of x here, I need to introduce natural logarithm both sides. And when you talk of natural logarithm, is a logarithm to a base of 10. So I will have logarithm of 2 raised power x to base 10 is equals to logarithm of 3 raised power 1 to a base of 10. That is how we introduce logarithms natural logarithms. And then from there, still from the loss of powers, I will take this x, I bring it this side. So I will have x logarithm of 2 to base 10 is equals to logarithm of 3 to base 10. And then from there, for me to obtain the value of this x, of course, I will divide both sides by logarithm of 2 to base 10 divided by logarithm of 2 to base 10, so that these two will cancel out. And then on this side, I'll remain with x is equals to. If you calculate log 3 divided by log 2 from your calculator, you will have log 3 is 0.47712, and then log 2 is 0.30103. So when you divide that, you will have 1.585. So the value of our x becomes now zero, no, not 0. The value of our x becomes 1.585. That's how we solve it. You need to introduce natural logarithms both sides, and then from there, of course, now you will make your x the subject of the formula, and then you will obtain the unknown value. So let us look at the last examples on the same. So our last example is this one. We are taught to solve 2 raised to a power of x plus 1 is equals to 3 raised to a power of 2x minus 5. So the same way, my people, so for us to obtain the value of x, we need to introduce natural logarithms both sides, simply because our values here are involving powers. You can see x plus 1 is our power here, and 2x minus 5 is our power. So in order to obtain the value of x, we have to introduce natural logarithm both sides. So we will have a logarithm to base 10 of 2 raised to x plus 1 is equals to logarithm to base 10 of 3 raised to 2x minus 5. We will have this kind of an equation when we introduce natural logarithm both sides. And then from there, the same way we've done the previous examples, I'll take this power here. Remember, my power is x plus 1. So I'll take this power from this side, I bring it to the other side. The same thing I'll do on the other side. I take this power to this side. So I will have x plus 1 logarithm of 2 to base 10 is equals to 2x minus 5 and then logarithm of 3 to base 10. We will have that. And then from there, when you find logarithm of 2, you will have x plus 1, then log 2 is 0.3010 is equals to 2x minus 5, and then logarithm of 3 is 0.4771. We can open the bracket. You can see our next step, of course, is to open our brackets, so that I'll have 0.301 times x, then plus 0.3010 times 1. So I'll have this times x is 0.3010x plus this times 1 is 0.3010 is equals to, if I take 0.4771 times 2x, I will have 0.9542x. Then this is the sign here is minus, so I'll subtract 0.4771 times 5. I'll have 2.3855. So when you open the brackets, that's what we have there. And then from there, you can see on this side, we have these parameters, and one of them is having a known x. And still on the other side, I have a value that has a known x. So now we're going to collect the like terms together. The terms with x on one side, then the other terms on the other side. So in this case, for me to make everything easier, I can take minus 2.3855 to this side. So I'll take this one to this side so that it becomes plus, and then I will take this 0.3010x to the other side. I'll do that so that on this side I'll have 0.3010 plus 2.3855 is equals to, I'll have 0.9542x, and then I bring this on the other side, it becomes minus. So I'll have minus 0.3010x. We have that. And then from there, when you take this 0.3010 plus 2.3855, you will have 2.6865 is equals to, when you take this one minus this one, you will have 0.6532x. We will have that. And then from there, of course, for us now to obtain this value of x here, I'll divide all through by 0.6532, divide all through by 0.6532. So these values will cancel out, and then I remain with x is equals to 4.11. That becomes our value after solving this equation here. So the value of this unknown x is 4.11. Thank you so much for watching. If in case you have any question, you can leave your comment. I'll look at it and make the necessary thing. Please, if you are new, subscribe, like, and God will bless you. Thank you.